Welcome back to the Impact Storytelling Podcast. I'm your host, Sabine M, conservation filmmaker and NGO director. And today I'm joined by Kate Inman. Kate is a marine biologist, conservationist, and science communicator with a growing voice in the world of marine science and conservation. She worked on everything from dolphin surveys to coral reef expeditions to turtle conservation, and her journey reflects a deep and ever-evolving passion for understanding and protecting life beneath the waves. You may know Kate through her work with the Marine Vertebrate Conservation and Research Unit at the University of Plymouth, and from her public outreach with the Explorers Club GB&I's Women in Exploration event, where she introduced audiences to the fascinating world of bioacoustics, listening to the ocean to better protect its species. Today, we'll talk about where her love for marine life began, what it's like to decode dolphin clicks and whistles, and how fieldwork, technology, and storytelling can work together to inspire action for our oceans. Welcome, Kate. I'm really happy to have you on the podcast today and talk with you about your journey. You've described working in marine biology as a lifelong dream. What does it mean to you now living it?
It's so special. I'll be honest, when I started going into marine biology at university and doing my placements and internships, I was a little bit worried because it's something that I've been passionate about for so long that then turning it into something that I'm doing full time and then it's also my passion, I'm not really getting a break from it. So I was worried it would start to turn into a real chore, but that absolutely hasn't been the case. I've just continued to love it, and I feel really fortunate that I get to do what I do and to work with and meet so many incredible people who do so many things within marine biology that I would have just never thought about before, and they're so fascinating, and I feel really lucky to be part of that community.
It's amazing how many people are working on marine conservation all around the world in so many different topics. And it's great to see that you have already gotten a lot of different experiences that we're going to talk about today. And what led you to study at the University of Plymouth, and what drew you to marine vertebrate conservation specifically?
So Plymouth is one of the best universities, not only in the UK, but one of the best in the world for marine biology. The staff and the lecturers are all absolutely incredible. They're all also researching at the same time, so they are some of the world leaders and the pioneers in their fields, which is fascinating. So one of the members of staff at Plymouth, Professor Richard Thompson, actually coined the term microplastics, and therefore is obviously a massive leader within that field, and it's a real privilege and an honour to get to learn from people like that. So that was something that really enticed me. Also, the city itself is amazing, and it's very much built on the ocean, and it has a real connection to the ocean, which is something that I really liked, particularly coming from a landlocked area. I wanted somewhere really nice and easy to get to the sea. In terms of vertebrate conservation, so things like whales, dolphins, turtles, sharks, all the big charismatic things that people often think of when they think of marine biology. I did originally go into my degree with an open mind because obviously that is a field that a lot of people want to do, and understandably so, because it is so fascinating. So I did go into my undergraduate having a look at some other areas and areas of research that might interest me outside of that or might bring me back into that through a different route. So, for example, going into something like physiology, which is how animals work, and then in the future, potentially it just working out that my area of expertise would end up being doing something working with one of those animals. But it was always something that I continued to be interested in, and it was always at the back of my mind a bit. And then at the end of my first year, I applied for a programme that the University of Plymouth run with the Manta Trust called the Ocean Giants Programme, where they train up 5 to 6 students a year in fundraising, the inner workings of a conservation charity, and then pair you up with one of these charities in loads of different places across the world. So I worked with Lamave in the Philippines. And then because I was getting experience and building my network in that field, and it was already something I was really passionate about, I really felt like it was just time for me to go for it. And I'm really glad I did, because it's definitely got me to where I am now and got me to meet lots of the incredible people that I've been able to work with.
It's definitely an amazing journey that you've already been on. And I also definitely agree on Plymouth. It's such a nice city. My ocean conservation journey actually also started at the University of Plymouth, although I was studying media. But I also joined some lectures and talks at the marine biology department, and it was really, really interesting. And yes, you just said you've had an incredible range of hands-on experience for someone really so early in your career as well. And how did these early placements, like with AIM Portugal and with La Mave in the Philippines, teach you about working in marine science?
I've been really fortunate that Plymouth as a university is really passionate about students and their community of early career scientists getting that hands-on experience, and that's definitely been the driving force behind it. For me, I always knew that the sort of science I wanted to do, I wanted to be out in the field. I have done some lab work as well, and that's been massively valuable in other ways, and I've loved it, but I've always wanted to be a field scientist. So I knew I wanted to get as much experience as possible, as early on as possible, not only just for the experience itself, but again, to meet lots of people within the field, to learn from them and to share ideas and experience with loads of people from across the world, because it makes such a big difference when you have all of these different perspectives going into a project. And it meant a lot to me to be able to go to these places. I feel very fortunate. I had a lot of support from my family. I worked 5 part-time jobs in my second year. And I got a couple of grants as well, because it was something I really wanted to do. So I knew I had to work for it. So that was really rewarding, though, because when I got there, it was that I got myself to those places. And I feel like I got to contribute some really important thoughts and ideas and practical work to the projects. And it's been really powerful for me to see how these conservation projects are working around the world outside of the UK as well.
Wow, it's amazing how driven you are working towards your goals. I'm sure you're a great role model to many who want to start in that field. It's really amazing. And you also recently talked at the Explorers Club Women in Exploration event. That must also have been a really powerful moment. Can you tell us a little bit about that?
That still, even a few months on, is a total pinch me moment, because that's probably been one of my biggest dreams and something that I was thinking about maybe I'd get the chance to do and achieve in a few years, certainly not already. So for those who don't know, the Explorers Club is an international society, and it's had members in the past such as Edmund Hillary, who's the first to summit Everest, Neil Armstrong, Buzz Aldrin's a member. So members have been the first to both poles and to the moon and to the summit of Everest. So some pretty incredible people, and now their focus has really turned onto exploration in the form of conservation, finding out things about our planet to help protect it rather than discovering new places, although that is still going on as well. So I became a student member of the Explorers Club about 18 months ago. I was sponsored by Fania Rose, who is an explorer and conservationist and was the first female president of the Explorers Club. So it was a real honour that she was in my corner fighting for me to be a member and felt like I was worthy. That was really special. And then each year, the Great Britain and Ireland chapter of the Explorers Club, which is based in London, does a speaker series, and they have different themes each time. So recently there was a World Ocean Day one. Previously there's been one celebrating the anniversary of the first summiting of Everest. And this one was about women in exploration, celebrating different women in exploration. And I got invited to go and talk about some of the work I'd been doing in my degree and my year in industry, which was absolutely incredible. And to be able to have that experience of talking to so many people with so many incredible experiences and so much experience of exploration, to see them fascinated in my work and asking questions about it was incredible. And to be on the stage and at the front with 2 other women, Eloise, who is only a few years younger than me, who has done loads of polar exploration, lots of expeditions to Greenland, and Dr. Neve Shaw, who is a space scientist and science communicator. And to stand alongside them and to have my work seen at that level was incredibly special, and I will never forget it.
I can only imagine it must have been a really amazing moment for you. I'm sure that's something people work towards for a really long time, and it's really special and amazing that you got to be a part of this at such a young age already. That really shows the work you do is really incredible and something to be really proud of. You've been exploring a lot, everything from dolphin surveys to turtle hatchlings. How do you approach fieldwork with such diverse species and contexts?
There's actually quite a lot of overlap between different field contexts. In terms of the actual science itself, it can really vary, but in how you approach working with a team and working with people from lots of different backgrounds, experiences, and perspectives, that's something that I've tried to take onto every project that I've done, wherever I've gone in the world, because, as I said, it's really valuable to make the most of all of those different perspectives and work together in order for this common goal and passion that everybody shares. And I think that's really important to focus on. Obviously, the science is what you're all there for, the conservation is what you're focusing on, but you can't do that without your team. So no matter which context I've been put into, that's been something that I've really tried to do. And I think that's something that I try and bring to everything that I do in my everyday life as well, and any other work I'm doing, because not only does it improve my work, it improves the outcome for everybody, and it's so much more enjoyable and everybody gets so much more out of it, and the science tends to be much better as well.
And what stood out to you during your time with the olive ridley turtles in Palawan? Was there a moment that especially moved you?
Palawan was possibly one of the most incredible places I've ever been. As you can imagine, in the Coral Triangle, beautiful beaches, incredible reefs. But for me, it was the people. So I was based out of a small village, or barangay, as they call it in the Philippines, as part of the project, living within the community and doing a lot of outreach, as well as the main science we were doing, which was going out and taking measurements of the mother female turtles nesting at night, and then moving the nest to a safe place, and then releasing the hatchlings when they hatched in 45 to 60 days afterwards. But none of this would be possible if we didn't have the support of the local people, and they were just absolutely incredible, supporting our project all the way, working with us, learning with us. Of course, this is their beach, their community, and their local area, so they know it best than anybody. So it would have been foolish not to bring them on board and to learn from them and work with them. And now that I've finished the project, I feel really confident that we're leaving the turtles and the nesting sites in safe hands with people who really care about them and have learned from us on the science side, and we've learned from them on the outreach and awareness side, and also just the understanding of the local area and environment. So for me, it really was the people side, and I'd say that for almost every, if not every, project that I've done, it really does come down to the people you're working with, and that makes it so special and really moving. And it's so powerful to see, for example, these young children seeing these tiny turtles go to sea for the first time on the beach outside their house. There's just nothing that beats it.
Are you working on outreach programs with projects like this as well, or just in a science setting?
So previously I've done quite a lot for the Manta Trust, who are the charity that work with the University of Plymouth on the Ocean Giants programme. So I've done some of that also on placement. I've done a little bit in terms of social media outreach, also some online virtual classes about manta rays in the ocean and conservation for schools, which has been really great. And now I do a lot more on the media side, and also things like the virtual manta ray adoption packs, which is always super fun and is a really nice way to get people in touch with manta rays and conservation as a whole in a really easy way, in a really lovely way, for people to have that sort of personal touch as part of supporting conservation.
For that turtle project, was there an outreach campaign or something you've helped with? Like the programs you said with the locals, where you learn from them and they learn from you. How did that look like?
We were really fortunate that the community really welcomed us in, and the time that we were there coincided with a local festival that they had, and they invited us to have a stall there, which was great. So we made some fun games. We made some about rolling a table around with handles on it to roll a ping pong ball from one end to the other, as if kids were trying to get a hatchling from the nest when it hatches down to sea, doing lots of fun games with the kids, like they could paint their own turtle shells to wear and walk around, and also tying in then that conservation message. So it was really lovely to be able to get involved in the same way that other organisations in the community were involved, and it really got us in touch with the people that we were working with, and we just wouldn't have been able to do it without them.
What would you say is the most interesting fact for you about marine turtles?
I think it's probably just how long they live. It's totally incredible. So, for example, leatherback turtles can live upwards of 200 years, which is why it's so important that we protect them, because they are a type of species that in biology we call a K-selected species. So this basically means that they live for a really long time, but they mature reproductively very late on, and they may not produce a massive amount of offspring or eggs at a time. So, for example, other examples are things like whales and dolphins, which may only have 1 or 2 calves at a time. Turtles, obviously slightly more in terms of the eggs, but it means that they are a lot more vulnerable. They're around a lot longer, and it takes them a long time to grow and mature. So while it's obviously amazing that they're living so long, it's an incredible thing that those animals are doing. It also is something that we have to really focus on with conservation as well.
What would you say is the biggest threat for turtles?
There is honestly a massive range depending on where they are in the world and which life stage they're in. So for things like the hatchlings, when they hatch, first of all, it's getting to sea. They have sort of an innate instinct to head towards the sea because of for example, the moon trail on the water, but then this can be disrupted by artificial light, so from human sources like hotels or houses or street lights on the other side of the beach cause them to go the wrong way, which is why it's super important for projects like the one in the Philippines that we're there to just give them a little helping hand. And then also on the way, it can be things like stray dogs, birds, things like that will eat them. Some of those natural, some of those introduced by humans. And then once they get into the sea and start to mature, it's things like ghost fishing. So these are abandoned fishing nets they can really easily get caught in, very hard to see. Things like long lining, where potentially the turtles are caught on hooks, and turtles, like whales and dolphins, but unlike sharks, have to come up to breathe. So unfortunately, if they're caught on these hooks, they can't come up to come and get air. So it is a real issue for them. Things, of course, I'm sure people are aware, like plastic. A lot of turtle species feed on majority of their lifetimes on things like jellyfish, which they can easily mistake plastic bags, plastic pollution for, or just become caught in it in other ways. So they're really, at every stage of their life, there can be something that's affecting them. Again, things like oil spills and oil slicks, not only can that cover their habitat at sea, but also the beaches that they're coming out to nest on as well.
And yeah, a lot of conservation work still has to be done there, so it's great that there are so many people working on it. And back home in the UK, you've been doing research on delphinids at Ream Head. Could you talk us through what your work has involved there? I understood you're analyzing diurnal patterns in the occurrence and co-occurrence of dolphin whistles and echolocation clicks. What have you observed so far?
This is really where my main passion lies, I think, in a field called bioacoustics. So this is looking at natural sources of noise from loads of different animals, but it's most commonly associated with dolphins because they're just so well known for their use of echolocation. In the same way that bats use it, they put out these clicks that reverberate off things nearby so they can hunt for prey and identify different things in their environment, and also their whistles that they use to communicate with each other. So it's a really valuable way of being able to tell where dolphins are and also potentially what they're doing in those areas. So I started doing work on bioacoustics in my placement year with Dr. Claire Embling at the University of Plymouth, and then ended up continuing to do that through my dissertation, which is then what led me to do some more research at Ream Head. So Ream Head is a headland just into Cornwall, so literally just west of Plymouth Sound, and the university has several hydrophones deployed out there on the seabed, and these are basically underwater microphones that just record anything that's coming along or making noise. That can include things like boats as well. But for the dolphins, I was then looking at something called diurnal patterns. So this is essentially just the daily patterns of whistles and clicks. So within 24 hours, when are they whistling the most? When are they clicking the most? Are those whistles different types at different times of day? And finding that looking at the particular whistle types, that they tend to be more active at night and also probably feeding at night as well, because that's when there's more whistles and clicks. In terms of the co-occurrence, that's a super cool kind of new field that I was looking at, and this is when whistles and clicks occur at the same time. It's been observed quite a lot, but it hasn't really been researched and looked into depth a huge amount. So we don't really know what it's for, but I've theorised potentially it's for that group foraging. So they're echolocating, producing the clicks to be able to find the prey, and then whistling to communicate with the rest of the group who are also hunting as well. But there's definitely a lot more to be found out there, which is super exciting.
It definitely sounds super exciting to understand them more and how they communicate with each other, what sounds they use for what. And what do their sound patterns actually tell us about dolphin behavior or presence in an area?
So obviously more whistles tends to mean more dolphins, less tends to mean less. Not always the case, but often so. And when you're looking at a larger data set over a longer period of time, if you're seeing that continuous pattern, it becomes much, much more statistically likely to be the case. So there can be different shapes of whistles that show up on something called a spectrogram. So it basically just makes an image of the sound. So the whistles can appear as different curves and shapes, and the different curves and shapes can mean different things. So the two most common ones are simple, as we call them, types of whistles called up sweeps. They just go up, and down sweeps. They just go down. So they start as a higher pitch and go down for a down sweep, start at a lower pitch and go up for an up sweep. They tend to be associated with feeding and foraging behaviours. There's still a lot more to identify about how we can link up different types and frequencies potentially of different whistles to different behaviours. But we've certainly made a start, and it's really useful to be able to compare that with the data that we're getting at the moment to be able to identify what behaviours dolphins are exhibiting at certain times and in certain places, and that can be used to see where potentially there is overlap with human noise.
Can you differentiate by the noise which dolphin you listen to, or what species of dolphin you listen to?
Not with 100% accuracy, but with a pretty decent accuracy. So the dolphins that we had on my set of recordings, my dissertation, were most likely common dolphins. Given the area as well, this isn't unsurprising, but we can work this out from the types of whistles. So mostly up sweeps and down sweeps does tend to be common dolphins. The mean frequency of the whistles and things like that we can use to make estimates. The other really useful thing about whistles as well is something called signature whistles. So this is a repeated whistle pattern that dolphins might use, and it's almost like a first name for humans that they might just repeat to others, and basically it's like me walking around just saying Kate at people continuously. But it's really useful for us looking at these data sets because we can see those repeated whistles on the spectrograms and in the recordings. So it's really helpful to be able to identify different individuals within a group as well.
Let's listen to a recording you have sent me of dolphins. So what dolphins did we just hear from you now?
So there we heard a lot of common dolphins, probably feeding, definitely some socialising going on. But the whistles within dolphins, we do know for sure that they are used as a form of communication between each other. So whatever they're doing, it's requiring a lot of communication with each other and a lot of coordination. It could be even something like travelling, but they're trying to coordinate that travelling in a certain direction. Unfortunately, as amazing as all these whistles sound, some of the recordings like that are super annoying when you're trying to do research because you have loads of whistles overlapping, which makes it really difficult to get out the numbers that you need, basically. So things like the frequency of the whistles, where the start and end point is. So it's great to listen to. And for example, that recording is one of my favorites ever. It's just the whole recording, which is about 15 minutes, is just totally full of those all the way through. But going through it from a scientific perspective, a little bit more difficult.
You must have really good listening skills to do this kind of research. I can imagine listening to that for a really long time must be really straining to the ear. Let's zoom out for a moment. What first drew you to bioacoustics? What magical story can you tell us about it and listening to the underwater world?
I've always been fascinated by dolphins and the way they communicate and how they socialise and how they build their own sort of communities and societies, and how much of that is founded on sound and how much they rely on sound to do that. So it was the focus of something I did in sixth form at school. So that's equivalent in America, for example, to 11th grade. Doing something called an EPQ, an extended project qualification. And this is basically a mini version of a thesis or a dissertation, where you choose an area of research you're really interested in and go away and do some research on it, and also do a presentation at the end about what you found. So I knew I wanted to do something marine biology, and I ended up reading a book called The Breath of a Whale by Lake Alves a couple of months earlier, and it really sort of sparked my interest more for the actual science behind what we're seeing in whales and dolphins, and particularly sound as the driver of some of those behaviours. And that's mainly what they're relying on for a lot of these behaviours. So I ended up looking into, for my EPQ, the effect of shipping noise on whales and dolphins, but also having a look at whether that has to be inevitable with development of countries, and whether that shipping noise is going to increase, whether the impacts of it inevitably have to, whether there's something that we can do about it. Because almost the nice thing about noise, as Dr. Ebling at Plymouth has said to me, and it's really stuck with me, is that unlike things like chemical pollution and plastic pollution, if we wanted to, it's not going to happen, but if we wanted to, we could just stop it today, just stop everything and switch all the noise off, which puts us in a really powerful position. I found that really interesting to explore how much of that we really have to have inevitably for our growth and stability, and whether the impact on whales and dolphins is potentially warranted. So that was something that always stuck with me as an interest. And then I went to university. As I said, I kind of had an open mind at what I wanted to do, but that was definitely in the back of my mind. And I had some lectures in the first year, sort of within the same topic, remained really fascinated, and reached out to Dr. Embling, told her I was really interested in what she was doing within the field. Ended up then doing the Ocean Giants programme, doing some travelling for different projects and placements, and then came back to the UK. And I reached out to her again and asked if she had any availability on her team to take on a placement student to work with some of this data. And she said yes. So of course I was absolutely leaping at the opportunity, and it's just become something I find so fascinating, mixing an interest I've had for a long time with sort of that real science and the technology side as well, and how we collect that data. I find really interesting.
Can you tell us a little bit more about how you collect the data and what exactly you're listening to? Are you just listening to whistles and clicks, or also background noise?
So there's two types of hydrophone that we use. One picks up the whistles, and that basically does a recording like the one we heard earlier. And the other one does something called detecting for the clicks. So the echolocation clicks are so high pitched that we wouldn't be able to hear them. So rather than actually taking a recording, every time it detects a click at that frequency, it basically just makes a note that there's been a click at that time, and you can export it as a spreadsheet basically to have a look at the different number of clicks you've got within a certain time frame, or something that a certain time that you're potentially interested in looking at. The great thing about that one is it's really easy to work with. It's just basically filed the data for you. For the whistles, that does just record everything. It's literally like holding a microphone in the water. So we get all of the background sound. So in the file we heard earlier, you'll have heard almost like a crackling sound in the background, almost like Rice Krispies or a fire crackling, and those are snapping shrimp. Basically just snapping away in the background, and kind of a normal background noise to have in that area, but it does mean that then we have to go through and identify those whistles. However, there's a lot of technology coming in now that is hopefully going to make that a lot easier by doing a lot of the detection of those particular whistles itself, which would save a lot of time.
Do you remember the first time you heard a dolphin whistle or a whale song, and how did that moment feel like for you?
It was sort of within the induction period of that placement I did in the UK, and having a look at some example files and hearing for the first time the sound of a minke whale in the UK, and also some humpback whale songs in the Indian Ocean. It was just incredible to get to hear it for myself from the original audio rather than edited or cut from anything, and to be able to see the shape of the song and the sound on the spectrogram and to identify it is just incredible to sort of enter into that world outside of the what does this mean, what are the implications, just to enjoy it and to think that these incredible animals are going around doing this all the time without even really thinking about it, and to be able to hear that is so special.
People often think it's really quiet underwater, but it's actually not.
No, yeah, it's a loud place, the ocean. A lot of it comes particularly from boat noise, but it's particularly on places like coral reefs, you'll hear a lot of noise, and it's really cool.
Yes, well, the boat noise is not so nice, and all the noise pollution, but hearing the clicking on a reef and the crackling, it's really beautiful to not only see it, but also hear what's going on there. I feel like when you hear that boat noise all of a sudden appearing above you, you just totally get ripped out of the, oh, it's so beautiful underwater, and get more in the realization, oh shit, we're doing a lot of things to the ocean. And it's not always visible, but you can also hear it. Although sometimes I also had experiences where then the boats were just on top were also throwing trash into the ocean, so then it's visible and audible. And yeah, it really makes you want to do something again for the environment.
Because we have such an understanding of how important sound is for mainly whales and dolphins, but also starting to look at other animal groups as well, it seems almost inevitable that there are going to be impacts from different human or anthropogenic, as we call it, noise sources. The main one is boat noise. We do have things like seismic surveys, sonar. So the pings from sonar, you can hear things like air guns and lots of different sources of that noise. Aside from it being a bit annoying, if you add the sound of a boat going over you all the time, it's probably not the most calming noise. But from a more biological perspective, a lot of these sounds operate at similar frequencies to the sounds that we're seeing these animals communicate at, which can cause something called masking. And this basically means that the whistles that maybe one dolphin puts out are going out of the same frequency as this boat noise, so it can't be picked up by another dolphin, which is stopping them being able to communicate effectively with each other, which can have impacts to things like socializing, foraging as a group, and therefore foraging success. It can also cause things like, for example, pile driving for wind turbines is a big cause, can cause something called a threshold shift. So we have temporary and permanent threshold shifts. This is where temporary means that some hearing damage can be done, but it can then improve back to normal or near normal levels, or permanent is where there's therefore permanent hearing damage. And with these marine mammals and these sorts of animals, that hearing is crucial to their survival, so it can have a real impact on how they're able to forage and communicate with others.
And what happens if they can't hear anymore?
It becomes really difficult for them. Obviously, this is something that's still being looked into quite a lot, to look at the real direct impacts that a lot of these sources of noise are having. But of course, while they may be able to whistle and communicate, they are very unlikely to be able to receive whistles and communications in return. And if they send out those echolocation clicks, it's possible that they aren't actually therefore able to receive them again and be able to detect where prey and other items are. So it can really make it difficult for them to socialise and forage.
Are there any particular acoustic recordings that surprised you or challenged your expectations?
I think it was just the sheer amount of boat noise that I've heard. And originally, when I started looking at data, I really thought that the boat noise would be, potentially there would be quite a lot. It's a busy area of the world. The English Channel is one of, if not the busiest shipping lane in the world. So it's unsurprising to have boat noise, but I thought it would be a little bit more of a diurnal pattern, again, like the whistles, where there was a lot of boat noise during the day, but at night it would be a lot quieter. And I hope this would be the case, because this is when a lot of studies have shown, and mine included, that that's when dolphins tend to be feeding. However, the boat noise was almost continuous. There was no real pattern, just from observation, that there was more boat noise at a particular time. So unfortunately, it looks like it's overlapping with the dolphins at any time of day. And that was really surprising for me, to know that was going on pretty continuously.
Do you think the public fully understands how noisy the ocean is becoming? And have you any idea how we can raise awareness about that invisible threat?
I think you've hit the nail on the head there. I think because it's an invisible threat, it's something that people may not think about as much, whereas things like plastic pollution, which is also a huge issue, don't get me wrong, but it's a lot easier to see the impacts that we're having. Even if you don't see it in person, it's easy to see in a documentary and to show people the scale of the problem. With the noise, it's very difficult, because we live in loud environments anyway ourselves, but we're better equipped to deal with it, and we don't rely on sound so much in the way that whales and dolphins do. So, for example, I did the talk at the Explorers Club to explain why dolphins and whales, among other animals, use sound so much. I showed them a picture of most of the sea, and it's basically just a black screen. So they're using sound almost entirely, because most of the sea, even during the day, but particularly during at night, pretty much all of it is completely dark. So it's the only way that they can navigate, communicate, and forage. So because we aren't living in that sort of environment, I think it's harder to understand, but I think it's equally as important as other threats that these animals are facing. It's something that is going on all the time and is having a constant impact on their ability to survive.
Any idea how we can make it more clear to the public that this is happening and that it's not good?
That's what I've kind of started to do, and I know lots of people have started to do, is to really show people some of these recordings that we're getting, some of the times that we're getting them, but also talk more about some of the sources of anthropogenic noise. So a lot of people probably would never have thought about things like sonar and seismic surveys, because it's just not something that you encounter in your everyday life, but they are having impacts. And there have been a lot of debates and a lot of discussion about how to still have sonar for the safety and security of different countries and forces, but also without it harming whales and dolphins. I think the only way to be able to share that with people is to really truly literally let them listen in to that environment, and to really see what we're seeing and hear what we're hearing.
Can long-term bioacoustic monitoring help us understand and respond to the changes in marine habitats?
It can help us to see where dolphins are, the patterns in where we might find them and when. And then the great thing that we can do then is also have a look at the patterns and frequencies and concentrations of different sources of human noise and identify where there might be that overlap. So, for example, on the south coast of the UK, we have a resident population of around 48 bottlenose dolphins, so a really small population in a relatively small area. So they're extremely vulnerable to these threats from things not only noise pollution, but things like chemical pollution, plastic pollution, and just general disturbance by boats. But part of that battle is being able to identify that group and to identify them as vulnerable. So bioacoustics can really contribute to things like that and being able to identify where there might be vulnerabilities along the coast.
So we've talked a little bit about marine mammals now, but what role do marine mammals play in the ecosystem? How does their conservation impact the wider health of our oceans?
Marine mammals, most if not all of them, are something in their environments and their ecosystems that we refer to as keystone species. So they're often icons of their particular environments. If you think things like sea otters in kelp forests. And they're also a really important part of that ecosystem that sort of brings everything together. So just to go back to the sea otter example, because it's a pretty famous one, when a lot of otters were killed in the late 20th century, so about 30 or 40 years ago, there was an increase then on the kelp forests in the Pacific that they'd been living on sea urchins. That's what the sea otters had been eating, and they've been keeping the sea urchin populations down at a suitable and regulated level. Now, the problem without enough sea otters is then there's nothing to eat the sea urchins, so their population just totally boomed, and then they graze on the kelp, which in small amounts isn't an issue, but in those big populations, basically tearing down kelp forests in a relatively short period of time, which is then taking away a whole habitat for a range of other important and endangered species. So that example really shows how important those marine mammals are, whether that be sea otters, whales, dolphins, seals, to their environments and to sort of holding that ecosystem together.
Yeah, there are examples all around the world that really show what can happen if there is an imbalance in the ecosystem. And you've seen a lot of it firsthand. Do you feel hopeful how we are responding to the threats facing our species?
Sometimes it can be difficult because I do see a lot of it myself. I remember when I went to Indonesia and seeing for the first time plastic in the ocean on a really massive scale, like almost a coat of it on the surface of the water in an area where we'd just seen turtles, was really worrying. And I know a lot of people, not only within marine biology, but across the world in any field, feel like there's nothing we can do and that we're going down a difficult path. But part of the reason I got into marine biology and joined this journey was because I wanted to make a difference. Some things we have lost, but I don't think that means that we have to lose everything. And I often say to people, I wouldn't be continuing to do this and working in this field if I didn't think there was hope and that we could make progress. Otherwise, what's the point? I think we can do something, and I don't think because some things we've lost that we should continue and just lose everything and let everything decline, because our world is so connected, all the ecosystems, so it's so important to look after what we have as much as possible and to understand how these systems work and therefore how we can protect them. So I do have hope that if we keep working and understanding and getting people on board is the main thing, then there is a lot we can do.
Yeah, there is really a lot of conservation work still to be done, but thankfully a lot of people are also working on that, communicating it, researching it. And I hope when we get the word out more and research more and spread the information, that more people are motivated to help conserve the ocean. You went to North Sulawesi, I hope I didn't completely butcher that name, with the University of Plymouth's coral reef expedition. What were your impressions of those reefs there?
It was my first time ever in the tropics and my first time on a coral reef. So, full disclosure, on the first time we were in the water, I did cry. It was just seeing it and seeing in that particular region, almost the centre of the coral triangle, and such pristine reefs, it was just the most incredible introduction and experience. So we were contributing to a project and some long-term monitoring that one of my lecturers, Dr. Miriam Reverter at the university, is working on, looking at change within the coral reefs, potentially before versus after COVID, so the effects of different levels of tourism, rising water temperatures, and the effects on the composition of different types of corals, and therefore different fish species that we might see on the reef and the impacts that's having.
Yeah, it's definitely an amazing feeling to see coral reefs for the first time and see, these little animals, how important they are to the ocean. Because if you just look from far away, you wouldn't think that, there is so much life. You've also worked on sea sponges. How does studying sponges fit in your broader interest in marine life?
Yeah, it's a good question because it's very different to the other sort of things I've done. So working with Dr. Reverter again, who I was with in Indonesia, I ended up looking at some of the videos that we took of different coral plots. And then I wanted to do some practical work as well while I was on my placement with her. So she introduced me to one of her master's students, Graham, and he was working on this species of sponge that is pretty much all over the world, bright orange sponge that we find just on the shoreline on rocky shores. And he was doing something, extracting spicules. So these are like tiny little microscopic glass rods that act as a skeleton for sponges, which are like corals, animals. They just don't look like it at all, but they are really cool animals. So doing these, like extracting these spicules, so adding lots of chemicals, putting them in the centrifuge to spin them around to separate the different materials. And it was very different to sort of the field work side of things that I was doing, but to get that lab experience as well is really important. It was really good for me to be able to start feeling competent and confident working with different lab equipment and materials, and also to get some experience working within a different area as well, because so much is actually transferable between different areas of science. No matter what group or animal you're working on, there tends to be a lot of overlap. So that was a really valuable experience for me.
Yeah, surprisingly, sponges are really interesting to me. When I first started diving, I didn't really know much about them. But then when I learned from the marine biologists I was filming with at the time more about them, they really sparked an interest in me, and I'm really eager to share about these little filter feeders now with my friends and in the conservation work I do. Can you tell us a little bit more about sponges?
They are definitely a unique type of animal. So there's lots of different types. And again, we're still finding out quite a lot about them because they're not sort of your classic charismatic marine creatures. So there hasn't been a lot of interest surrounding them in the past, but definitely after doing that work, mine has certainly grown. So they have these glass skeletons made of spicules, of glass rods, which is really cool, which holds them in lots of different shapes, and these shapes can vary based on where they are in the world and in the shore. They're filter feeders, so they suck in lots of water, suck out all of the food like plankton that they want, and then push out all of the clean filtered water once they've taken the food out. They can make, and this is something that's being looked into a lot by pharmaceutical industries now, they can make lots of incredible chemicals and lots of sort of antibiotic chemicals as well to keep their sort of microbiome as they want it. So they work with lots of microorganisms on their surface and in their bodies as well to carry out the processes they do day to day. Lots of them are colonial, and most of them are colonial, so they tend to stay in one place their entire lives, but often there's lots of different little colonies, so those are actually individual animals that are all living together in basically a massive mat of sponge, but they're always super cool to see.
That's amazing. There are so many amazing living things in the ocean that we know so little about. Do you see a greater need for integration between vertebrate and invertebrate conservation strategies?
I think there is a lot of overlap, and we're only just beginning to understand that overlap. So, for example, within bioacoustics, we're starting to look a lot more now into invertebrate sound production and reception in things like crustaceans, so crabs and lobsters, and things like coral reefs. And if you've ever been on a coral reef, you know they make this sort of crackling, buzzing noise when you're in the water, and that comes from everything living on the reef and is really important for helping young fish and larvae to find where to settle. So sound is really important to invertebrates as well, and a lot of the methodology and the way that we work with vertebrate and invertebrate sound is really transferable. So I think it would be really great to sort of integrate that a lot more.
Your role in social media and outreach for the Marine Vertebrate Research Unit sounds really interesting. What's your strategy in communicating science to a broader audience?
I feel like I've had, compared to some people, a relatively easier job because I've had all these lovely pictures of things like manta rays and whales and dolphins, which people are always going to engage with, whereas plankton biologists and microbiologists have got their work cut out for them. So I was halfway there already just in the nature of what I was doing, but no science would be possible without the support of people. At the end of the day, it's important that people back science and back the science that's being done, and things like working to fight climate change and noise pollution and plastic pollution are going to be a global effort. So it's really important that people know what work's being done and potentially how they can contribute and how they can support that work. So as part of the Marine Vertebrates Conservation Research Unit, I was putting out some information on the marine mammal surveys that the university does by yacht each year in the summer, what their findings were, what things they were seeing, but also information about papers and research that some of the staff in the unit had done, and also information about how some of their research had contributed into the Western English Channel being designated as an important marine mammal area. So it's all about getting that information out there about the output of the work that we're doing.
As you have already mentioned, you've worked with the Manta Trust on media and education. What have you learned about balancing scientific accuracy and accessibility?
It's a really important thing, particularly for charities and NGOs, and I've done a lot more since then as well with other groups helping to support them with ensuring that the science is accessible for everybody, but also that we're sharing the right information at the right level and ensuring that it's sensitive to everybody. So particularly when we're working in lots of different countries and regions, we want to make it clear that we're working with those countries and regions and not coming in, taking data and leaving. So I have to be really sensitive to make sure that we're promoting that work in the right way so that people can see it how it is and how we're supporting these regions and groups as well, rather than just the science itself. Because as I said with the Philippines, it just wouldn't be possible without them, and these groups and perspectives enrich the work that is done. So it's really important to highlight that. But one really important part of the work that I've done is getting kids involved, getting that next generation of people interested in the environment and in science. So as part of the Manta Trust on my placement, I created something called Manta Marvels, and these are basically kids' versions of scientific papers, which is great not just for kids, but also for anybody to start at that level, because scientific papers can be really difficult to read sometimes and quite a task to go through them. So it's really important to make that science as accessible as possible for as many people as possible, because that's how we get people on board with the mission of conservation.
What you've done for the kids sounds amazing. I will link that below so that people can have a look at that. And for the last question, when did you think about public engagement in marine science? What's one thing you wish more people understood?
Oh, that's a good question. I think it's that we're all aiming for this common goal, and that this outreach and sort of trying to gain awareness that scientists and people are doing is not to try and get something from people, it's for their benefit. Sometimes it's really easy to see things like plastic pollution and coral bleaching as a really far away problem, but our oceans are so connected. Our planet is 70% water. I know a lot of people do the same. I tend to refer to the oceans just as ocean singular because they're so connected, and I always want to remind myself to see it like that. So everything that we're doing in conservation isn't just protecting, of course, these gorgeous little baby turtles, but is having an impact on the ecosystems that they're part of, and therefore us as well. So getting everybody stuck in with conservation benefits everybody, and that's why it's really important to have as many different people involved as possible.
Thank you so much for having been on the podcast and all the questions you answered. And I'm really looking forward to the future of your career, and I hope I see you soon again on the podcast. Thank you.